In my first example, I want to find any local extrema and intervals over which this function is increasing or decreasing. Now, anytime I look at my function, f of x, in this case we have a rational function, I just want to note off to the side here that I know that x cannot equal plus or minus 2. Okay? If x were plus or minus 2, we'd have 0 in the denominator. We know that those are going to have to be vertical asymptotes in this situation. So to find local extrema, let's begin by finding critical points. So we'll find critical points by taking the first derivative, setting it equal to 0. In this particular example, this will be required to use the quotient rule. So we have the low times the derivative at the top minus the top times the derivative at the bottom over the bottom squared. Let's do a little bit of simplifying. So f prime of x is going to equal negative x squared minus 4 all over x squared minus 4 quantity squared. Let's now set this rational function equal to 0. Begin solving. In solving a rational function, we'll set the numerator equal to 0 once we have that common denominator. Add 4. So x squared equals a negative 4. We know we can't take a square root of a negative number, so we have no critical points. Okay, knowing that we do not have any critical points, that's okay. We won't have any maxes or mins, but we still will have intervals of increase and decrease. Okay, so looking back at our original function again, because I know that it's not continuous at plus and minus 2, those are the values I'll use to set up a number line just to help me stay organized. So negative 2, positive 2. We'll plug values into the first derivative to determine whether or not this is increasing or decreasing. So my first test point I'll choose, negative 3. If we plug this into the first derivative, we're going to have negative 9 minus 4, which is a negative value. The denominator is always going to be positive. Doesn't matter what I plug in there, with the exceptions of 2 and negative 2, but we already know that that is not defined. Okay, so this was negative. So therefore, I know that I'm decreasing from negative infinity to negative 2. Plug in a value between negative 2 and 2. Pick 0. Again, going back to my first derivative. Once again, looks like we have a negative. And then going to 2, plugging in 2 to my first derivative. Once again, we are negative. So we're decreasing over every interval.